So over the recent pandemic, I got into making handheld games consoles. This is clearly a Nintendo Game Boy Color, but it's also, if we have a look in there, it's got a Raspberry Pi Zero in it. It's not the Zero 2. I actually made this before the Zero 2 came out. And I made this so long ago, and it was so stressful and took so long and was so iterative that there's no point of me trying to, make any sort of how-tos. But I thought I'd just make this video just to kind of show how it ended up, because I'm really happy with the way it works. I sort of set myself like a design brief for this. I wanted it to be exactly the same as a normal Nintendo Game Boy Color. So I haven't, hot glued any shoulder buttons to the back of it or anything like that. If you were blindfolded, it would feel more or less like a regular Nintendo Game Boy Color from 1999. To the point that in order to get the sort of vertical height inside the device, I took let's just pull you down a bit. I took a Game Boy Color cartridge and chopped the back out of it, and then glued it in place here. So it looks like there is a Game Boy Color cartridge installed, but there isn't. You can't actually remove this. It's just there to give me some thickness on the internals, just to play with. So that's that, and then walking around it, all the stuff works like you'd expect it to, except for the COM port. That does nothing. Let's pop it back up a little bit. The COM port does nothing. The volume wheel is the original volume wheel, and believe it or not, controls the volume. And the on-off switch turns the thing on and off. The face buttons do the face buttony stuff. It does get a little bit different underneath the battery door. There you go. There's a whole bunch of stuff in there. And that is the charge controller and the sound card, and you plug it into charge just like this. So there's another USB-A connector in there at 90 degrees, and that just come on, pop it like that. Yeah, you should be able to see that the red charging LED is on. So that's how the lithium-ion battery inside this thing is charged. So that's sort of what it looks like on the outside. Before I pop it open, to show you how I made the insides, let's just have a look at what it looks like. So that's the original power switch again. This might take a few moments. It's the one thing that's really hard to emulate is how quickly the original systems booted up, because they were just running in hardware, whereby this is a computer that has to boot the OS, load the software. In fact, the last thing it does is start the driver for the display. So it just takes a few moments. And there we go. Must be the first time I saw it. It was pretty cool. The sort of scrolling text on on a Game Boy. It's running Emulation Station or RetroPie, or is it called RetroArch? I never know what this piece of software is really called. I go to retropie.org to download it, but then it seems to be called by a bunch of different names over its development history. And there we go. Ta-da! So even though we've got the limited face buttons of the Nintendo Game Boy Color, just two face buttons, start and select, and then the D-pad. There are a fair few systems that use this control scheme. I've got here in the moment the Game Gear, the Game Boy, and the Game Boy Color. I think that's it for the moment. Yeah, there we go. Just around to the settings and the favourites. But there is also the Neo Geo, which had both an original and a colour version, I believe. Lots of interesting Japanese games to play on the old Neo Geo. There's a bunch of other things you can emulate with just this. There's a couple of retro computers, I think, that the games, they had a joystick that only had, a directional pad and like one or two buttons, so you can emulate those as well. So you see this kind of thing now and again with extra face buttons popped in the front, or sort of shoulder buttons glued on the back. I didn't really want to do that. I thought if I was going to go that extreme, might as well just try and actually make a thing from whole cloth. So that's a 3D printed games console that I'll get into later. This is just about this guy, and you can hear there that it's got some sound. And just to show you a game, my left button's out of commission at the moment, so we'll just have to go and do this quickly. So go. Just saying that every game is somebody's favourite game. Well, this is my favourite game. This is the game I really wanted to play. Sort of, I know that I'd completed this project when I was able to play Halley Wars, which is a game for the Game Gear, actually. So it's a bit weird. You get a Sega loading screen right above where it says Game Boy Color. And yeah, this was the game that me and my brother lost the first few thousand hours of our life to video games. We lost to Halley Wars. And that's the volume control just working there. Yeah, so that's the original Nintendo volume control. This is a shooter. I can't go left here, so it'll be pretty quick before I'm completely out of options. You've seen a shooter before. Yeah, can't go left. Oh well, I know exactly what that is. But yeah, it's RetroArch. It does the thing. Let's have a look at the inside, see how this thing was made. Right, so here we go. Ta-da! Look at that. So I will flip it out in a second, just so we can have a look at the front side, as we can see the screen and stuff. But I think I can sort of just give you a bit of a guided tour around this as it is, and it should make a lot of sense. The reason I'm making this video is just that I know this is a very popular project. Sadly, I've got very little how-to for you, but this is just to show, what something at the end of this project might look like. So there's a couple of bits of the original Nintendo PCB in here. So down here, I chopped the PCB up. This white bit here is the backing for the buttons, because of course the membrane switch is, half of the switch is on the printed circuit board. It's the exposed pads. So I needed that to make the original buttons work. And then this piece of circuit board has the original power switch on it, and this piece of circuit board has the volume pot on it, and also the EXT connector. Like I say, I haven't connected that up to anything, but it just makes it look sort of complete from the outside. Then you'll see in the middle there is a Raspberry Pi. So Raspberry Pi 0W1. It wasn't called that then, but it's the first one. And underneath that is the lithium-ion battery. There you go. So just in there, that's the lithium-ion battery, 1000 milliamps, and that does the that powers the device. So then what have we got connected to the Raspberry Pi? We've got this bundle of wires here, which come off the GPIO around here, and this bundle of wires is the SPI connection to the display. It's using the High-framerate SPI. There are my better tweezers. It's using the High-framerate SPI display driver. I'll stick the name up on screen now. I think if you're doing one of these kind of projects, you need to be familiar with that piece of software. So that's how I'm driving the display. The buttons are all hooked up to the GPIO pins as well. So each of these wires hooked up to an individual GPIO is a different button. And I'm using the Adafruit Retro Arcade jobby. Basically, it's a piece of software that reads the GPIO and turns it into keyboard inputs. So the system thinks you're pressing a keyboard whenever you press a button connects to one of these wires. The SD card, I knocked off the little cage that holds the SD card. I'm actually quite heavy-handed, despite sort of enjoying these sort of electronics projects. I knocked off the little cage that holds the SD card in place. And it was just at the start of the pandemic when sort of these supply chain issues were starting to crop up. So my replacement Raspberry Pi was taking so long that I actually just soldered on this SD card, pin for pin, pad to pad, just soldered the SD card straight in place. So not the kind of device you want to be swapping OSs on regularly. What else is connected to the Raspberry Pi? The sound card. So this is a little USB sound card. It's just a really simple device that has a USB Type A connector on one end and then an audio jack on the other. I've taken off the USB connector and the audio jack, and I've just wired it directly to 5 volts, and then the data plus and data minus from the Pi Zero's singular USB ports. and that's how we get half decent audio out. And then I guess we can talk about this bit as well. This is the battery charger connector power thing. It's sort of an integrated module. You get them on Banggood, like £2 or £3, and it's got 6 connections on here. It's got 2 connections for 5 volts in, so you can see you can just plug a USB Type A jack straight into it, but this one wasn't really, you know, in the right orientation, so I got another one there, and then just wired that up there and there. You connect a 3.7 volt lithium ion battery across here, so it deals with charging. So you plug in 5 volts into here, and this bit deals with charging the lithium ion battery. It's even got a red and a green light for charging and charged. And then on this side of the module is a 5 volt power supply. So that takes whatever the battery voltage is. Obviously it changes as it, you know, depletes and charges up, and turns it into a nice clean 5 volts at about 1.5 amps. So, you know, 7 or 8 watts of energy to power your projects with. And then basically I'm just switching this 5 volt supply with the battery, with the Game Boy's original power switch. So that's sort of everything on that side. Let's just go ahead and take another screw out. Okay, now this is always slightly terrifying every time. Man, I'm amazed this thing is as rugged as it is. So that's the kind of the front side of things. So that's the very recognizable chopped up printed circuit board from Nintendo. That's my SPI display. You'll notice the SPI display is actually larger. This is a 2.8 inch display, I think, which turns out to be perfect in that direction. So I've just made sure that I've sort of centered it horizontally on the Game Boy's, you know, screen aperture. Just with these 3D printed pieces, packing it off the internal geometry of the Game Boy's case, and then to make sure to kind of chop off one side of it, I've used the overscan function in the Raspberry Pi's config.txt, just to chop off a little bit of one side of the display. I guess it's that side. Yes, yeah, I think. Yeah, that side is correct, and then I chop off sort of this area of the screen here, just using the Raspberry Pi's built-in overlay functions. Let me try and center that, shall I? So that's the screen being driven over SPI. That's all good. And then basically the sound works by the left and right audio come off the little sound card on the back onto the volume potentiometer. And then so that's left and right in, and then left and right out after it's been, you know, after the volume's been controlled. And that left and right output lands here on one of these very familiar modules. It's a PAM something. I'm sure you'll have seen these little chips before. It's a 2-channel amplifier. So it takes the sort of the headphone level audio that's, you know, coming from the volume control pot, and it's amplifying that and driving this little speaker, which is the original Nintendo speaker. So yeah, learning all of that took me weeks and weeks and weeks. It seems almost trivial now I've actually made it. But yeah, that's the solution I chose. It's all about, when you're building one of these, it's all about choosing what solution you're going to go through. Are you going to try and get sound out of the Raspberry Pi's GPIO connector? Are you going to try and power it from some AA's, or are you going to try and squeeze a lithium LiPo in there? There's a whole bunch of different... Oh dear. That's not boding well for sound. That's the connections from the... Oh, I'll need to resolder that afterwards. Okay, well, maybe I won't close this up then. I don't want to bore you with just me fiddling around with soldering iron. But yeah, that's how I got this working. I have actually, the audio does actually hit the headphone output as well, so you can plug headphones in, and that is after the volume control has been applied as well. However, plugging it in causes the system to restart. Don't know why, but it does. So yeah, I haven't really finished this to the kind of the, you know, to the point where I could be really confident about saying, you know, do it just like this. This was definitely a creation, you know, step by step, 3D print by 3D print. All of these sparkly red parts are 3D printed parts. I 3D printed. They're sparkly red because this was around Christmas and that was the only colour of filament I had. So it's a fairly festive design on the inside, I think. But yeah, that's how I went and made my portable Raspberry Pi powered handheld. There we go. And now I've got to try and work out how to squeeze it back into the shell. That's the wire look that was blocking me from pressing the left button. There's a little control wire there that sort of wants to be more like that. And yeah, I need to do some soldering on the audio side, so I'll sort of leave that there. And then just to sort of show off the route I'm going for in the future. So this is all well and good, but I do really want to sort of make something that sort of I could sort of demonstrate to other people how to make their own Raspberry Pi handheld. So this is the original circuit board. You can see how it matches that bit there. That's what a Game Boy Color circuit board made by Nintendo almost 30 years ago looks like. And here's something I made recently. Yeah. So there you go. You can see that side of the screen has been blocked off. So the Raspberry Pi doesn't treat this half. Oh, so I was wrong. It's actually this half of the screen that's being overscanned out. But yeah, this is a printed circuit board of my own design that receives a Raspberry Pi Zero. This does not work. In fact, it took 2 weeks. I got in such a mania trying to, thinking about this. I ordered some prototypes of this one, expecting to, hand solder all of the, the components. But yeah, by the time I actually got these, the design had moved on tremendously. But that's the sort of route I'm going through. Actually, putting all of the, the audio chip and sort of some sort of microcontroller. I'm thinking a Raspberry Pi Pico, an RP2040, to sort of do hardware control and button presses. And yeah, an amp and a headphone jack to do sound, but that's all something else for the future. So there we go. That's my Nintendo Game Boy Color Raspberry Pi Zero conversion. Got any questions? Leave a comment below. Thank you very much for watching. Have a great afternoon.